I can add and subtract rational expressions. Woohoo! Rational expressions, that means fractions. You've got to know how to do it with numbers, so you can do it with variables. Now, adding and subtracting rational, also known as fractional expressions. Okay, so algebraic fractions are challenging, but you can do these problems. The secret is to work slowly and show all of your work. Don't skip steps. Fractions are fractions. It doesn't matter if the fractions are made up of numbers or variables. The rules are the same. The basic rule for adding and subtracting fractions: get a common denominator. Now, let's look at the process. We're going to start with something very basic. 1/3 plus 3/4. The smallest common denominator is called the LCD, or least common denominator. In order to do this, I cannot reduce or cancel those 3's. Don't do that. This is not multiplication. So, step 1, get the common denominator, the smallest number that both denominators can divide into without remainders. In this case, the number is 12. To change the denominator of 3 into 12 requires multiplying by 4, both top and bottom. I've done that. To change the denominator of 4 into 12 requires multiplying by 3, top and bottom. It's not really by 3, but by 3 over 3. This is the multiplicative identity. Multiplying something by 1 does not change its value. With each fraction, whatever is multiplied times the bottom must also be multiplied times the top. Again, the multiplicative identity property rules here. Now, we have 4/12 plus 9/12 is 13/12 is 1 1/12. I personally prefer you to leave it like this. Do not add the common denominators. Add only the numerators. In multiplication, you multiply numerators and you multiply denominators. When you're adding and subtracting, you do not do that. Multiplying the top and the bottom by the same number is multiplying by the multiplicative identity element, which is 1, and therefore does not change the value of the fraction, just the form. Now, we're ready to look at some algebraic fractions. Hooray! On to the bigger things. First, 3x over 4 plus x8. Well, what's the LCD? Why, 8, of course. So I can multiply by 2 over 2. The x over the 8 I don't have to change. Turns into 6x over 8 plus x over 8, which is just 7x over 8. Now, in this case, there are no restrictions on the variable because the variable only appears in the numerator. So there's no chance of any value causing this particular rational expression to become undefined. Next up, we have 1 over 6x plus 2 over 3x minus 3 over 4x. We have 6, 3, and 4. Take the 6. 3 and 4 won't go into 6. Multiply the 6 by 2. We get 12. 3 and 4 will go into 12, so we're going to use 12 as our LCD. I multiply by 2 over 2, by 4 over 4, and by 3 over 3, giving me 2 over 12x, 8 over 12x, and 9 over 12x, resulting in 1 over 12x. Now, in this case, I also have to add the restriction that x does not equal 0. As long as x does not equal 0, everything's good. The other thing you want to be careful of is the x is in the denominator. Make sure it stays in the denominator and doesn't look like it peeks out and comes out and all of a sudden is standing on its own. Here's another one. A minus b over ab squared plus a plus b over a squared b. Least common denominator is a squared b squared. The largest power needed for both a and b in this problem is a power of 2. So the first fraction. Over here, I need to multiply it by a over a. The second one by b over b. And I do that. And voila. Remember, when working with binomials like a minus b and a plus b, think of each binomial as one entity. For example, in a minus b, the a cannot go anywhere without his buddy negative b tagging along. You can never reduce cancel. Only the a or only the b in a minus b. Really important here. I can't cancel these a squareds or that a. Now, I could take an a out of this and an a out of that, but then I'm going to be back to what I have in the beginning. Not helpful. Be sure you understand what you're doing when you cancel. Finally, when I do this, I put it all together. A squared minus ab plus ab, these two cancel, and I just have a squared plus b squared. When we add in this problem, the ab terms are eliminated. Now, notice that I cannot cancel the a's and the b's. It's because it's a squared plus b squared. This is the same thing as a squared over a squared b squared plus b squared over a squared b squared. If I want to cancel stuff, I will get 1 over b squared plus 1 over a squared. I can do that. That's fine. But I can't just get rid of the a's and the b's on the top. I do have to note as well that a does not equal 0 and b does not equal 0. I do have those restrictions. Like I said, this is not necessarily reduced. I can leave it like this. If you do it like this, that's fine. Number 4. Pause the video and try this one. There's some hints over on the right-hand side, but pause the video, try this one, and then start it again. See how you do. Are you back? Well, let's see. I have a, then I have a minus 5. My greatest common factor is a times a minus 5. So I have to multiply a minus 5 over a minus 5 and then a over a. I distribute the 2. Whoops. I distribute the 2. Oh, goodness. Wrong place. And on the bottom, I wouldn't multiply those out. There is the possibility, I would leave them factored, that after I finish everything in the numerators, I might be able to factor something out. So I wouldn't go through the trouble of multiplying those out yet. So now I've got I've got 2a minus 10 plus 3a. That gives me 5a minus 10 over a times a minus 5, or 5a minus 10 over a squared minus 5a, or 5 times a minus 2 over a times a minus 5. Doesn't matter. Any one of those are perfectly fine ways to express the result. A does not equal 0. A does not equal 5. You do have to have the restrictions on. Now, here's another one. The least common denominator in this case is x minus 6, x plus 6. How did I figure that out? Well, this right here is a difference of squares. Right here, I've got a greatest common factor. So when I worked those out, I had x minus 6, x plus 6, x plus 6. This is common to both of them. So therefore, I don't have to worry about that. Here, I do have to multiply this one by x minus 6 over x minus 6. And this guy I have to multiply by x over x, which I do in the next one. Instead of just multiplying the two denominators together, find the common denominator. It makes it smaller. If you multiplied both of these by if you multiplied x squared minus 36 over x squared minus 36 and x squared plus 6x over x squared plus 6x, you're just going to get this ugly, awful beast that has to be further reduced. Here, 2x minus x plus 6. Distribute the negative. Distribute that minus. Then, once I have that all set up, okay, I've got 2x minus x is just x. This leaves me with x plus 6 in the numerator. I have an x plus 6 in the denominator. It reduces to x, or to 1 over x times x minus 6. Remember, x does not equal 0, x does not equal plus or minus 6 because I have to look at the original. Be careful when combining fractions under subtraction. Be sure to subtract the entire numerator value behind the subtraction sign. In this particular problem, when subtracting x minus 6, you do minus 6 or minus x plus 6. Both of these denominators were factorable. Factoring is your friend. Factoring lets you find the smallest common denominator quickly, thus making your end result easier to work with. Here's another one. It's a little tricky at first. At first, it appears that we're going to need to multiply both denominators to get the common denominator. But look a little closer. Did you see it? If I multiply the numerator by -1 and the denominator by -1, this guy can turn around and become 2x minus 6. See that? I distribute the -1. Now I have the same denominator. I didn't have to change much of anything other than the sign in the numerator. Beware, you will see problems like this on quizzes and tests. Finally, when you add 3x minus 9, you factor out the 3, and then you can reduce. Now, even though your answer is 3/2, you still have to pay attention to your restriction. X cannot equal 3. If you multiply one of the denominators by -1, you create a factor that matches the other denominator. When multiplying one of the denominators by -1, be sure to multiply the numerator by -1. Remember, -1 over -1. This technique can also be accomplished by factoring out a -1 from one of the denominators. Ha! Thought you were done, did you? You know you've got to practice to get good at it. So pause the video and try these. Come back and I'll display the answers. Pause. You're back. Froggy1 says, did you get 7x over 9? No restrictions, no variable in the denominator. Froggy2, 9 over 8x. X does not equal 0. If x is 0, then the original as well as the final answer are undefined. Good job. Oh, you're not done yet. Try these two. Determine the LCD first, least common denominator. Pause the video. Welcome back. Hopefully you're not looking as sad as the little fish here. And hopefully when you see this answer, you're jumping for joy because you got it right. This one's a little daunting. It feels so much like you should be able to simplify it somewhere, somehow, but you can't. Next up, were you successful? Did you do it? I hope you did. Don't forget, answers aren't complete without the restrictions. Here are two more. Notice these are just like the ones I did with you. On the left, make sure you factor before you decide on your LCD. And on the right, remember, we did the tricky one? This is a tricky one too. Pause the video and try these. Okay. Here are your two answers. Oops, pull them up a little bit. Were you successful? Did you remember on the left to distribute the minus to both the x and the -2? I hope you did. Then 2x minus x is just an x. All right, did you get all the restrictions correct? If you need to wait and look at this a little bit more, pause the video. Look through the work. Make sure you understand all of it. In summary, adding and subtracting rational expressions follows the same rules as adding and subtracting numerical fractions. Find a common denominator. Sometimes you must multiply one or more add-ins by a form of 1, the multiplicative identity, to achieve a common denominator. Other times you can factor to a common denominator. Once you have that common denominator, add the numerators, or combine them. Combine like terms. Be careful with subtraction to distribute the negative properly. Then simplify the result if possible. Don't forget your restrictions.